Today we're going to talk about SimCenter TestLab Neo, and in this 2206 release, there's a new method called the block calculate. Let me go to the first slide here. So as an overview, calculation on block data, how does it work? Any type of 2D block and or single values can be used in the block calculate method, and the process designer input is still only throughput data in 2206. So what that means is we're going to put time histories in the input basket. And then here I have an example if I'm going to bring up my mouse pointer here. So basically I'm going to put throughput data in my input basket. I'm going to calculate a spectrum map. From that spectrum map, I'm going to calculate some order sections, some overall levels, and some frequency sections. I'm going to bring those into the block calculate method. I can also calculate some statistical values. So here I'm calculating the min and the maximum statistic for my order sections, and then bring those in the block calculator as well. And then I have another chain here where I'm calculating a spectrum average. I'm calculating time varying loudness, maybe calculating sound pressure level, and those also go into the block calculator. So the input to the block calculator can be any two-dimensional block I'm calculating in a process, as well as any statistical value I'm calculating in the process. And there's a distinction between the block calculator, which is block data, so basically process data, two-dimensional process data, or the calculate method, which handles time histories as well as single values. So both the block calculator and the calculate can take statistical values, which are single values, but block calculator takes 2D process data, and the calculate method takes time histories. Very similar interface to the calculate method. So this is an example of the block calculate method. On the right side, we have different columns we can use, and then these columns can be used to select data. So here, for example, we're showing the DOF ID, the function class, calculated statistics, and the section value. So here, the first four, I'm picking particular orders, order 2 and order 4. Here, I'm picking an overall level. Here, I'm picking an order section, but this is going to pull all orders, so second order and fourth order. And then here I'm calculating or showing the maximum statistic of the second order. And then I can use these identifiers in the bottom where I'm doing some calculations. And here I'm calculating several averages, as well as calculating an envelope, as well as calculating a vector sum. And I'll show these when I do the demo later. I'm going to go through the slides first and now do a demonstration. So at the top part is the identifier definition. And there we're going to basically sort the data and store it in identifiers that start with 1 by R, the letter R by default. And then we're going to use those in formulas in the bottom section. And the formulas usually start with an F. You can change that function ID if you want to a different letter or a different ID. But by default, it starts with F1 and increments. Same thing with the identifiers at the top. It starts at R1 and increments. So the top part is the input, and the bottom is the output of this calculate method, this block calculate method. Here's an example of the identifiers. So we've got the property list, like I said, that you can bring in for input blocks or single values. Here's an example where we've got an identifier. We've called out a very specific DOF ID and the order section and second order. So this results in exactly one curve. So this is one curve with this DOF ID with the second order. So it's identifying a single block. This one is identifying multiple blocks. So here we've got second order defined, but we're defining binaural asterisk. So it's going to find the left ear and the right ear. So this would have 2 blocks instead of a single block. Here we're creating the formulas. So as you start typing a formula, it gives you some syntax help. So I've typed in AVE, and it's complaining that it doesn't find that formula. So I need to start typing average, and then it would no longer give you that syntax help. So you can see average, envelope, vector sum, offset. These are some of the available commands. So function class, if the operation on blocks of the same function class, the function class is kept. So if I'm doing a formula using only orders, then it's going to keep the function class as order. If the operation on blocks of different function classes, the output is changed to user metric. So if I'm trying to do some math where I'm maybe dividing orders and overall levels, or maybe adding several different sound quality metrics together, If those function classes are different, it's going to change the output block to be a user metric rather than keeping the input function classes. If I modify the function description in the formula, it's also going to call it a user metric. Points and directions. User can define a dedicated point ID or direction. If none is defined, the resulting block will have the same as the first identifier. So here, for example, we're calculating the envelope of R5, and I'm changing the name to be envelope binaural, and I'm not going to change the direction. So whatever the direction is on the original data, it's going to keep that direction. Vector sum R6, I'm changing the point ID to be vector sum seat. So we're doing the vector sum on the XYZ direction of the seat, and I'm going to set direction to none. If I don't do that, it's going to find the direction of the first channel, X, Y, or Z, and specify it there. Average R1, direction no change. So whatever I'm averaging, it's going to keep the name of the original data as the point ID, and it's not going to change the direction either. So there's options for point ID and direction if you wanted to take from the first function it finds, or if you want to specify it manually yourself. Units, we can handle units 3 different ways. We can handle units automatically. So then based on the calculations, it's going to set the units automatically based on those calculations. Or I can assign it to any unit that's in the unit system. Or if their units aren't compatible, I can use either the ratio or the pound sign as unit tags. Some other various topics, x-axis information, all input blocks used in the formula need to have a common x-axis. So if you're calculating orders, they all need to have the same speed axis. If I'm calculating something on averaged auto powers, they need to have the same frequency axis. And the resulting axis is the same as the tracking axis. So if I'm calculating a waterfall based on a run up or a rundown, and I'm calculating orders and overall levels from that, I can look at the tracking axis that's used when I calculate the spectrum map, and that's what's going to be the resulting x-axis after my block calculate method. Some additional options, I can store the results in a new run I wish, and I can just specify the run name, and I can also keep the inputs and outputs. So if I'm going to use the results of the block calculator method in additional methods, maybe I want to keep the input feeding into it as well as the output. By default, we just keep the outputs. So these are options. When you go into the block calculate method, you'll see the formula set we can open up, and you'll see the run name, as well as the option keep input and output. So here's an examples as well. And it looks like here's a result of the block calculator result being stored in its own run. So let me show test lab. So here's test lab, and I have one run in my input basket. So in my input basket, I have one run with a couple of channels. It's got one microphone channel here, a gearbox. And then it's got some accelerometer data. So here I have XYZ, for example, of this differential I'm going to use. And then in my method here, I'm going to calculate a spectrum map, basically tracked on engine speed. I'm going to calculate overall level. I'm going to calculate second and fourth order. I'm going to calculate 100 and 200 hertz frequency section. I'm going to take it to the block calculate method. In this method here, I'm going to specify for 3 orders, second order, same 3 orders for fourth order. So here I'm using the channel ID to find my channels. Here I'm using the DOF ID. So these 6 are actually the same. And then I'm going to show you what I wouldn't suggest. So this is going to do the math on second and fourth order for channel 1, channel 2, channel 3. So here I'm calculating the average, max envelope, and min envelope. These are exactly the same average, max envelope, and min envelope. So the first 3 are using the channel ID to do the calculations. 4, 5, and 6 are using the DOF ID to do the calculations. And down here, it's going to combine second and fourth order. So I'm going to get the maximum, the average, and the min envelope for second and fourth order for channel 1, channel 2, channel 3. So those last 3 might have some unexpected results. So if I want, I could run this. Look at my active analysis here. So these would be my three different averages for the differential channel. Okay, so there they are. There they are for the max envelope, and here they are for the min envelope. Okay, so that's one formula. If I look at another formula, so let me reject those. And let me turn that guy off and turn this one on. So in this block calculate method, this is where I'm showing vector sum for my overall levels. So there I have my overall levels chosen in the top, overall level for differential x, differential y, differential z. I'm also specifying with diff asterisk, so that's using a wildcard. So that's going to find all three of my overall levels. And then here I haven't specified the function class. So see how it says time here? This is what I was telling you about. If I come down to this block calculate to method and click run to, and then go back to that formula set, here it's going to combine or try to combine auto powers, frequency sections, overall levels, order sections, and time. So that's not going to work so well in this last function. So this would give the vector sum of the three directions. This would give exactly the same vector sum of the three directions. And this would try to combine across multiple function types. So if I reject that guy, and now if I run the process rather than run to, I can start to see this is RSS. This should give you hopefully the same curve. Legend's on, so if I make it a little bigger. So those two are exactly the same. And then the third one, I should probably get some unexpected results. Oh, so that is working. So I must be grabbing the first orders by default, but I wouldn't trust that formula because I'm not really sure what it's doing. So I'd be leery of this last formula here because it could combine across multiple function classes. And if I turn this one off and go to this one, I think this is the one where I'm going to do some scaling. Nope, that's a different vector sum. So this is basically all the vector sum. So if I wanted to calculate the vector sum for the overall levels, for second order, for fourth order, for this 100 Hertz section, this 200 Hertz section, it would require these 5 formulas here. And I can give it the same point ID, and then we can determine which is which by looking at the function class and the section value. So if I reject this guy, and if I run this, so this is my overall level RSS. This is second and fourth order for the overall sections, order sections. This is my 2 frequency sections. So these are all my different calculations for my vector sum. So if I want to show another section here, so if I go to signature analysis scaling, this is where I'll show the scaling. So here I have a very similar process, but now I'm calculating statistics. So I'm taking the overall level, the order sections, the frequency sections, and calculating statistics. And I'm going to feed that to the block calculate method. So I do run 2 here. If I look at this formula set, here I'm bringing in the second order and fourth order, and I'm looking at the maximum value statistic. And I calculate RMS and max, so I could do either one. And then I'm finding second order and fourth order, and then I can use those in formulas. So here I'm normalizing R3, which is second order, and this should be by R1. That was the mistake in the slides. And this should be R4 divided by 2. Okay, so this is normalizing second order by its maximum value. This is normalizing fourth order by its maximum value. This is dividing second order by 10. This is dividing fourth order by 10. This is adding an offset of 10 Pascal to second order. This is doing the same offset using the offset command. This is the same offset specifying linear units. Here it's implied. And here I'm adding 10 dB as an offset. So if I reject this, and now if I run the whole process, okay, so this is where I've adjusted it. So that's divided by 10. This is where I've normalized it. This is a scale by 10. This is the second time I scaled by 10, and this is the third time I scaled by 10. So you can see there, they're different, the same. And then I should have one where I do it with dB. Okay, so that one's quite a bit higher now. So these three should be similar, and then this one's different. Okay, so that's where I'm doing some scaling here, okay, with these different formulas. So now I'm going to show a sound quality calculation. So if I reject these results, so now let's switch to another section here. I'm going to go to the sound quality metric. So now we've calculated time varying loudness, time varying sharpness, fluctuation strength, and then I've combined them into a formula down here. So now I'm saying 2 plus 30 times fluctuation strength plus 0.8 times time varying loudness minus 45 times time varying sharpness. I didn't give it a point ID because you could have multiple channels you're doing. So here I'm doing all channels, it looks like. So then I can calculate that. It's giving me a warning that these methods only accept pressure. So I didn't do a pass command. So if I wanted to see all those warnings here, it's telling me time varying loudness, time varying sharpness, and fluctuation strength only takes pressure quantity. So it ignored my other channels there. I could have done a pass with only pressure let through, and then I wouldn't get those warnings. But I can look at those results now. So this is this user metric, and there it's been calculated. Okay, so we could do math on any 2D function as shown here. So let me go back to my very first section, and let me go back to the slides. And then what I put here in this last slide is, if I go into the block calculate method, so go to the block calculate method, I can go to the documentation, and I have the documentation installed locally, so it finds it. If you don't have it installed locally, you can go to Support Center and find the commands available there. And there's a command on the block calculate, and there should be a command on the calculate method as well. So the calculate method is kind of broad, and it shows a lot of the basic operators that can be used in the calculate and the block calculate method. So here's basic operations, basic functions, conditional. And then there's some that are exclusive to the calculate method. So these only work on time histories. And these are exclusive to block calculate. So these work on process blocks. And the ones unique to the block calculate are the average, converting to dB, the envelope, which can be a min envelope and a max envelope, adding an offset like I showed you, and vector sum like I showed you. All right, well, everybody, thank you for your time.